Hello everyone. Today we'll solve the Leetcode problem number 206, reverse linked list. So what the question says, given the head of a singly linked list, reverse the list and return the reversed list. So here let's just see the example. In the example one we can see 1, 2, 3, 4, 5. So we have to reverse the list and return the reversed list, right? Nothing but in this case the output should be 5, 4, 3, 2, 1. So the output is 5, 4, 3, 2, 1. So the second example and the third example is similar. The third one we have not given any input, so we are just returning the empty array. And the second one is 1, 2. The output that we have to get is 2, 1. So let's write the code and understand with this example, the example 1, right? So initially what I'll do, let's initialize the 2 pointers, previous to null as well as current to head, nothing but the starting or the initial point. So I'll just come here, let me give previous comma current equals null and head. This is one thing. Previous to, we have initialized previous to null and current to head, nothing but the starting point or the initial point. Next, let's iterate through the linked list until the current becomes current becomes null. So I'll just make use of while for this. Current, while current is not equal to null, so we are iterating through the linked list until the current becomes null, right? So while current is not equal to null, what we'll do, we will store the next node. Nothing but I'll just name the variable future, store that one to current dot next. Current initially will be the head itself, right? We have initialized the current to head or the initial point or the initial value, nothing but in this case 1. This will be what we'll be doing. We'll be storing the next node basically in the future. So we'll be setting this one to current dot next. Next, what we'll do, we will reverse the current node's pointer to the point to the previous node. For that one, I'll just simply write current dot next is equal to, correct, right? Previous. So after this one, what I'll do, let's move the previous pointer to the current node. Nothing but we are stepping forward in the reversed list. I'll just, in the simple terms, I'll just give previous equals current. After this, finally what I'll do, let's move the current pointer to the next node in the original list. Nothing but we are stepping forward, right? So I'll just give current equals future. Finally, here is one. Just give me a second. So after the loop, what we'll do, previous will be pointing to the new head of the reversed list. Nothing but we are returning previous here in simple terms, right? So I'll just format the code. Let me hit the submit. So let's wait for some time. So you can see the code is correct. One thing. Next, let's see by taking this example, right? We have 1, 2, 3, 4, 5. Just give me a second. We have 1, 2, 3, 4, 5 and the output has to be 5, 4, 3, 2, 1. Let's see with this example. So we have considered example 1, 2, 3, 4, 5, right? We are setting this one current to this one head, nothing but the first value. This one current is 1, the head is 1, and we are checking current is not equal to null. Nothing but current is 1, right? It is not equal to null. The future is current dot next. Future is current is this one. Current dot next becomes this one. Now the future is 2 and the current future is 2 and the current dot next becomes previous, nothing but this one. Now the previous is 1, right? Previous is 1 and future is 2. Future is 2 and previous becomes current, nothing but 1. previous becomes current, nothing but 1, and current becomes future. Future is nothing but 2 now. So the reverse link so far is 1 as well as this one pointing to null basically. So the current list what we got is 2, 3, 4 and 5 because the current is 2 and the previous one is null. We are returning the previous, right? So what we have 1 and null. So next in the next iteration the current list is 2, 3, 4, 5, right? So the previous just give me a second. Future is current dot next, nothing but current dot next. Future is 3. No, just give me a second. Yeah, future is 3 and future is 3 and previous is current dot next is equal to previous, nothing but this one. Current was 2, current dot next is previous is future is 3, current dot next is set to previous 1 and previous moves to the current node 2. So and the current moves to the future. Future remains 3 and the previous becomes this one 2, right? So we are returning the previous, nothing but now we have got 2, 1 and null. So now the list we got is the current list is 3, 4 and 5, right? So this is the second iteration. And the third iteration, the current list is nothing but 3. The current list you can see in this list is 3 and so I'll just delete these two numbers in this case. So the current list is 3, right? This one. And future stores the next node. Now let me write, just give me a second. Future is nothing but current dot next, this one. Future is nothing but current dot next, nothing but 4 and current dot next is set to previous 2 and the previous moves to the current node 3. So the previous will become 3 according to this one. These things, right? We are checking for. Previous is now 3 and the current moves to future 4 and we have the previous 3 and future 4. We are returning the previous, right? Now we have 3, 2, 1 and null. So the current list is 4 and 5. So in the next iteration, we will check for previous and future, right? So just give me a second. Here, the future stores the next node 5. So basically, current will be next set to future, but the future will be 5 itself. So future will be 5. Current dot next is set to previous 3, and in the next step, previous is set to current, nothing but 4 here, right? And current moves to the future 5. Current moves to the future 5. Now the previous is 4, future is 5, right? We will return the previous, nothing but 4. Now we got 4, 3, 2, 1 and null. So next, the current list will be only 5, right? Next, the future stores the next node null. We have null, right? Next to this one, we don't have anything. So the future will be null. I'll just give n. And the current dot next is set to previous 4. So the previous, after setting this one to previous 4, previous moves to the current node 5. Nothing but previous is 5 now. Previous is 5 and the future is null. So we will be next, this one, current moves to the future null. So we'll be returning the previous, nothing but here 5, 4, 3, 2, 1 and null. So a reverse link, so far as 5, 4, 3, 2, 1 and null. So the loop exit, now the loop will exit, right? As the current is now set to null. The next number is, we have null. This one is null. the current will be null. So we will carry out these iterations when current is not equal to null. So now the current is null and the loop will now exist. And the previous points to the new head of the reverse link, nothing but 5, this one. We have the reverse linked list now, which consists of 5, 4, 3, 2, 1. So we have the reverse linked list now, 5, 4, 3, 2, 1, nothing but the output. We have to get 5, 4, 3, 2, 1. So yeah, this is it. And let's speak of time and space complexity, right? Just give me a second. The time complexity would be big O of n. Why the time complexity is big O of n? Because the function traverses the linked list only once, where n is the number of nodes in the list, right? So the function traverses the linked list only once, where n is the number of nodes in the list, and the space complexity would be big O of 1. Why the space complexity is big O of 1? Because the function uses a constant amount of extra space for the pointers. What are the pointers that we made use of? Nothing but previous, current and future. The function uses only the constant amount of extra space for the mentioned pointers, right? In our case, it is previous, current and future, regardless of the size of the input list. So the time complexity would be big O of n and the space complexity would be big O of 1. Just give me a second. Just come here. Let me write time complexity is big O of n and the space complexity would be big O of 1. So I'll just comment this one. So yeah, this is it. Thanks for watching, guys.